So now we're going to be talking about partial fraction decomposition, which is actually just an algebraic application of systems of equations. So we'll be using some systems to help us solve them in the middle. To begin with, we're going to start with a problem that I hope you already know how to do. So if we had 3 over x plus 4 plus 2 over x minus 3. Do you know how to simplify that by combining it, by adding the two fractions together? Okay, so if you do, maybe pause the video and try it and see if you remember exactly what to do. If you're very uncertain, then you can watch me do it. Okay, so to add fractions, we need to remember that we need a common denominator, right? So we're going to multiply the first fraction by the other denominator, x minus 3, on the top and the bottom. And we're going to multiply the second fraction by x plus 4, the denominator of the first fraction. And we're going to do that to the top and the bottom. And then we're going to kind of see what that equals out to. So we have the numerator is 3 times x minus 3 plus 2 times x plus 4. The denominator is x plus 4 times x minus 3. That's that common denominator. Notice it has both denominators from the problem. Okay, so now we just want to simplify it a little bit more. We probably want to distribute and see if we have some like terms on the top. So that's 3x minus 9 plus 2x plus 8. And the denominator, we might want to multiply that part out to x squared plus, let's see, the outer term is actually minus 3x. So I'll do that one next, minus 3x. The inner term is plus 4x, and the last term is minus 12. All right, so then on the numerator, it looks like we have 3x plus 2x being 5x. Negative 9 plus 8 is minus 1. The denominator is x squared plus x minus 12. And notice that there's nothing else we can do here to simplify. We're going to leave it like that as our answer. Okay, hopefully that looks really familiar. It is stuff that you've done before. And especially just with the fractions, it works the same with rational expressions, which is what these are. Okay, so now what we want to figure out though is, this is the new part, how do we reverse the process? Okay, so what if we had this fraction and we wanted to decompose it into two parts, into two fractional parts that would be added together that would equal that? So how do we decompose it, which means break it back apart? Okay, before we find out how, we do need to review first what a proper rational function is and what an improper one is. So a proper rational function means that the numerator, or the degree of the numerator, let's say, degree of the numerator is going to be less than the degree of the denominator. Okay, and in other words, this problem that we just came up with is actually a proper rational function because we have degree 1 on the top and degree 2 on the bottom. An improper rational function then is the rest. The degree of the numerator, why are those words so long, is greater than or equal to the degree of the denominator. Okay, so if this fraction was flipped over, it would certainly be improper. Strangely enough, if the degree on the top is the same as the degree on the bottom, that's also called improper. Well, we've already studied rational functions before, and when we had improper functions, we were using long division or synthetic division to simplify them. So I'm going to write that. You can use long division on those. So if we wanted to break those improper fractions down, we could use long division. We already have a technique. For the proper rational function, you really can't use long division on this problem because 5x minus 1, you'd be dividing it by something bigger. That wouldn't really work in the process. So for this partial fraction decomposition, it's actually only going to be on proper rational functions. Okay, well,